Welcome to
Nay.
Do it.
channel everyone. Okay, wow. Episode 2026-0320. And we are diving deep today. We have a fascinating paper to unpack. It's about how large language models, the LLMs, actually think when they're given a really tough job, like analyzing raw, messy binary code to find security holes.
Exactly, Isabel. The standard view is we give the model a task, it thinks step by step, and we get an answer. But this research asks a much more subtle question. What is the asterisk shape of that thinking? Over hundreds of steps, does any structure emerge? Implicitly.
And the key word there is asterisk, implicit asterisk. These aren't rules the programmers wrote. This isn't a traditional algorithm with clear if-then statements. They're finding patterns in the token-by-token reasoning traces. It's like studying the footprints of the model's thought process.
So it's forensic psychology. For AI, I love that. Instead of just asking, did you find the bug? We're asking, how did you walk around the code to find it?
Precisely. They analyzed a massive data set, 521 different binary programs, resulting in nearly 100,000 individual reasoning steps. And within that chaos, four dominant implicit patterns crystallized.
The first one is brutal and efficient, early pruning. The model quickly dismisses huge sections of code as irrelevant. It's not exploring every alley. It makes snap token-level judgments. This path is not promising. Move on.
That sounds smart, but also a bit scary. What if it prunes the wrong alley, the one with the vulnerability?
Which leads perfectly to the second pattern, path-dependent lock-in. Once the model starts going down a promising path, it shows a kind of intellectual inertia. It becomes committed. It's harder for it to suddenly reverse course, even if new evidence suggests it should.
But it's not completely stubborn. Hence pattern 3, targeted backtracking. It doesn't just start over from scratch. When it hits a dead end, it can selectively rewind its reasoning to a specific earlier decision point and try a different fork. That's a sophisticated form of revision.
Okay, so we have pruning, commitment, and smart backtracking. What's the fourth pattern? The conductor of this orchestra.
Knowledge-guided prioritization. The model uses its pre-trained knowledge to guess. This function name sounds dangerous. This code structure looks like a common vulnerability type. Let's investigate this area first. It's directing its own attention.
So these four patterns together, they form a kind of ad hoc management system. It's how the model, with no explicit instructions to do so, organizes its own exploration. It's not random wandering.
Exactly, and the study shows these patterns have distinct roles and measurable characteristics. Early pruning happens, early. Lock-in establishes a direction. Backtracking and prioritization happen throughout to refine the search. It's a stable, emergent system.
This is foundational. For the first time, we have a systematic way to characterize how LLMs perform this complex analysis. Instead of a black box that says vulnerability here, we can start to see its reasoning footprint. This is crucial for building more reliable, more auditable AI security tools.
It makes the process less of a magic trick and more of a traceable investigation. We can see the detective's notes. That's huge for trust.
And for improvement, if we understand these implicit patterns, we can potentially design systems to reinforce the good ones, like better prioritization, and mitigate the risky ones, like excessive lock-in.
Amazing. Thank you both so much for climbing this ladder with me, from binary code to AI psychology in one conversation.
Thank you, Isabel.
Thank you.